What's up everybody and welcome to a new video. And in this video we're going to start building our Minesweeper game, and we're going to start with the game grid. And first we simply want to initialize it. So therefore I'm going to create here a class in this helpers.py file. So let me first create here a comment that says class definition. And then here we're going to create our class, and we're simply going to call this Minesweeper game. And then within the class we're going to first define our init method. So with that init method, then we want to initialize here our game grid. So we're going to say self.grid, and this should then be equal to something. And the way that I want to represent this grid is in the following way. Namely, I simply want to use here a list of lists, where then here those inner lists here represent the rows of the grid. Then the elements within those lists represent here the columns. And then here the string containing the space, this will represent an empty cell within the grid. So now let's create here such a grid. And therefore we're simply going to use a list comprehension. So let's create here a list. And with that, then we're going to say for underscore in range 9. So we want to first have 9 rows. And then here, let's first simply create those inner lists. So now if I run it like this, then we get here this outer list containing those 9 inner lists. And then here for those inner lists, we can again use a list comprehension. So here we also say for underscore in range 9. So we also want to have 9 columns. And then here we simply want to have our string containing the space. So if I run it like this, then now we get here our game grid. So that is the code that we're going to use. So let's copy this into our helpers.py file. And now we could leave the code like this. However, I want to get rid of these magic numbers here. And therefore I'm going to create some constants. So let's first create here a comment that says constants, and the first one is simply going to call n rows, and this is going to be equal to 9. Then the next one is going to be called n columns, and this is also equal to 9. And then I would also like to replace here the string with the space, and this is going to then simply going to be called cell empty, and this is going to be our string containing the space. So now let's replace here the magic numbers with those constants. So these will be the n rows. Here will be the n columns. And then lastly here, the string is going to be replaced with this cell empty constant. So this is now how we initialize our game grid. So therefore then we can check off here the first point in our to-do list. Then next we want to create a method that places mines on our grid here. So therefore let's define here another method, and let's call this place mines. And here for now we're just going to put in the path, and then we're going to go back to this notebook here to work on the code for this method. So first here I'm going to import this helpers.py file, and since that is in the same directory as this notebook, I can simply say import helpers as h. And then I want to create an instance of our class here. So I'm going to say game equals h.minesweeper game. And then I also want to print out the grid again. So now what I want to do to implement here this method is the following. So I want to create a new list which contains the coordinates of all the cells in our grid here. And then I can simply randomly sample a specific number of cells from that list. And then I can use the coordinates in that list to place the mines in our grid here. So that's what we're going to do now. So let's first create the list that contains the coordinates for all the cells in our game grid here. So therefore we can again use a list comprehension. And in this case, we're going to then say for r in range h.n rows. Then we're going to use another for loop, and we're going to say for c in range and then h.n columns. And then we want to store these coordinates here into a tuple. So we're going to say here, or we're going to create a tuple and then say r, c. And now if I run it like this, then we get here this list which contains the coordinates of all the cells in our grid. So for example, this first coordinate here is 0, 0. So this would be this cell here, which is in row 0 and then column 0. Then the next coordinate would be here this 0, 1. So this would be this cell, which is also then in row 0, but then in column 1. Okay, so this is now the list that we have. And now let's store that into a variable, and we're going to call this simply all cells. And now what we can do is we can simply randomly sample a specific number of cells from this list here. So therefore we're going to need the random module. So we're going to import here random. And then here what we can say is simply random.sample, and we want to sample from all the cells. And then here we can specify how many cells we want to sample. So for example, if I put in here 5 and then run the code like this, then we get here this list which contains the coordinates of these 5 cells. And if I run this again, then we get here a new list. So now again, let's store this list into a variable, and we're going to call this cells with mine. And then next what we're going to do is we're simply going to loop over this list here and then use those coordinates to place a mine in our grid. So to do that, we're going to say for r, c in cells with mine. And then to create here a mine in our grid, we're going to say game.grid brackets r to access the respective row, and then brackets c to access to the respective column. And then we're going to set that equal to a mine, and the mine is going to be represented by this asterisk operator here. So then here at the end, let me again print out the grid to see what that looks like. So now if I run it like this, then you can see that we now have this grid where there are these 5 mines here in these different locations. And if I run it again, then the mines now are in different locations. So this will now be our code for this place mines function. However, before I copy it into our helpers.py file, I first want to get rid of this magic number here. So therefore, I'm again gonna create another constant, and I'm gonna call this simply n mines. And I'm gonna set that equal to 10. So I want to have 10 mines. So then let's put it into this code here. And then here, this string, I also want to replace with a constant, and this one I'm going to call cell mine, and this is going to be the asterisk operator. So then let's also put this constant into our code here. And then if we run this code here again, then you can see now we have here this grid with 10 mines, and if I run it again, then those mines now are in different locations. So our code is now working, so we can now put it into our helpers.py file. So let's first put in this import statement. So we're going to import random, then we're going to put in here the n mines. So let's put them together with the n rows and n columns, and then this cell mine we're going to put together with this cell empty. And then here we can copy this code into our place mines function. And then here obviously we can get rid of this h dot, because we don't need it within helpers.py. And then here, instead of saying game.grid, we're going to simply say self.grid. So that's now our final place mines function. And then what we're going to do is here in this init method, we're going to simply call this place mines method. So we're going to say self.place mines. So this is now our final code. So therefore then we can then here check off the next point in our to-do list. And then next we want to create a method that shows the grid, i.e. that prints out the grid. So therefore then let's define here another function, and we're going to call this show grid. And here again, we're just first going to put in here a pass, and then go back to this notebook to create the code for this method. So one thing that we could do is, for example, simply loop over all the rows here in our grid and then print out the respective row. So in order to do that, we can simply say here for row in game grid, and then we want to print that row. So if I run it like this, then the output now looks like this. And here, however, I would like to get rid of all the needless stuff. So for example, I would like to get rid of these brackets here. I would like to get rid of these quotation marks, and I would like to get rid of these commas here. So in order to do that, what I'm going to do is I'm going to loop over the row here. So I'm going to say for cell in row. And then since I want to print all the cells of a row on one line, I'm going to create here another variable, which is then simply called line. And this is going to be an empty string. And to that empty string now, I'm simply going to append our cell here. And then after the for loop, I'm simply going to print the line. So now if I run it like this, then the output looks like this, where we then print out the actual content of those cells. So the spaces and here these asterisk operators. However, that's obviously not what we want to do at the beginning of the game, because at the beginning of the game, we actually want to hide the actual content of those cells. So now what we need is, we need a character that represents that this cell is still hidden. And therefore, I've prepared here this black square character, which I then stored into this cell hidden constant. So that's the first thing that we need. And then the second thing that we need is that we somehow need to keep track of which cells were already revealed and which cells are still hidden. And therefore we're going to use an instance attribute. So we're going to create another instance attribute and we're going to call this cells revealed. And this is going to be an empty list. So to this empty list, then during the game, we're going to append the coordinates of the cells that we are revealing during the game. So for example, one coordinate could be here a tuple, which contains then a 1 and a 1. Okay, so those are now the things that we need for our show grid method. So then here, the first thing that we need to do is we need to access here the coordinates of this respective cell. And therefore, we can use the enumerate function. So instead of looping here over game.grid, what we're going to do is here we're going to call the enumerate function and we loop over that. And then here we can say row index, comma row. And then we're going to do the same thing here for the row. So here we're also going to call enumerate. And then here we're going to say column index, comma cell. And then we're going to store here these indices within a variable. And we're going to call this cell coordinates. And this is going to be a tuple, which contains the row index and the column index. And then what we're going to do is we're simply going to check if these cell coordinates are here in this cells revealed list. If they are not in the cells revealed list, then we want to hide that respective cell. If they are in the cells revealed list, then we show the actual content of that cell. So we're going to say here, if cell coordinates not in game.cells revealed, then the cell should still be hidden. So we're going to say here cell equals cell hidden. Otherwise, we're going to show the actual content of the cell. So this is now our code. So now let's run this to see what it looks like. And if I run this here, then you can see that now all the cells are hidden except for this one here, which is already in our cells revealed list. However, this now looks a little bit cramped. So therefore, I would like to spread it out a little bit. So therefore, then here, instead of adding the cell, what we're going to do is we're going to add an F string. And here we have then a space, then the placeholder with the cell, and then another space. So if I run like this, then now everything is now spread out more. And this is now what our code looks like. So this is what our function here could look like. However, I would like to add more, one more functionality. Namely, I would like to add a border around this grid here. So therefore, to do that, I'm going to make use of these box drawings characters here. So the first one that I'm going to use is this one. So first I want to create here a border on the left side. So therefore I'm adding here this vertical bar to this line variable at the beginning and then simply add here a space. So for now, run it like this. Then we have here this vertical bar on the left side. So now let's do the same thing for the right side. So therefore then here, we're going to say line plus equals, and then here a space, and then this vertical bar again. So if I run it like this, then we now have here this border on the right side. Now let's do this same thing for a border here on the top. So therefore, what I'm going to do is here in front of these for loops, I'm going to create another print statement. And here let's first add a comment that says grid upper border. And then let's also add here a comment that simply says grid. So this is going to be our actual grid. And then here let's add a print statement where we then use here these characters. So these are going to then represent here the corner of our grid. So now let's use here this horizontal bar or horizontal line here to add here a border on the top. So therefore then let's simply add that to this string. And then here, since we have 3 characters for each cell, so we have here a space, then a cell, and then another space, we're gonna need this horizontal bar here 3 times. And then we're also gonna need that for each column here. So we're gonna multiply that with the number of columns. So if I run it like this, then we have now here this horizontal bar, and now we now need here the characters for this corner, and I've already prepared those here. So let's add those here to this print statement. And now if I run it like this, then we have now our upper border. And now lastly, let's also do the same thing for the lower border. Therefore, we can just copy this and then paste it into here. Then here we're going to say lower border, and then we're going to replace here these characters that go down with characters that go up. So this is the first one, and then here also on the right side. And now if I run it like this, then now finally our grid looks like this, where we have this border around the whole grid. So this is now what our code for this method looks like. So now let's paste here this code into our helpers.py file. So let's first paste here this cells hidden constant. Then we're gonna paste here this cells revealed attribute, and we're gonna put that into our init method. And then here we're gonna say self. And then obviously this should be an empty list, because at the beginning of the game, there are no cells revealed yet. And then lastly, let's also copy here the code for this show grid method into helpers.py. And then we're going to indent that. And then here again, we don't need this h dot anymore, because we are already in the helpers.py. And then here, instead of saying game dot, we're going to say self dot. So this is now the final code for our show grid method. So therefore then we can go back to our nodes MD file and then check off here this to do in our to-do list. So with that then we've covered all the to-dos with respect to the game grid. And then next we want to work on the cursor movement. And here we first simply want to render the cursor. So therefore then we need to keep track of where the cursor is currently at. So therefore then we're going to create here 2 new instance attributes. So the first one's going to be called cursor row. And this is going to be equal to n rows. And here then we're going to use integer division by 2. And that's because we want to place the cursor in the middle row. And then we want to do the same thing for the column. So we can just copy and paste this line here. And then instead of saying row, we're going to say column. And then here, instead of saying n rows, we're going to say n columns. So now we can use those cursor coordinates here in our show grid function to render the cursor. So therefore, I'm going to first create a new variable, which is going to be called cursor coordinates. And this is going to be a tuple where the first element is the cursor row. And then the second element is the cursor column. And then the way that we want to represent the cursor is in the following way. Namely, instead of having here these spaces around the cell, what we're going to do is we're going to put here these brackets around the cell. So those brackets then represent our cursor. So then what we're going to do is we're going to say here, if our cursor coordinates are equal to the cell coordinates, then we want to render the cursor. So let's indent this here. Otherwise, we simply want to render here these spaces around our cell. And that's already everything that we need to change. So now let's see if that is working. So therefore, let's go back here to this notebook. Then let's run here this first cell. And then let's call this show grid method. So we're going to say game.show grid. And now if I run this, then you can see that the cursor here is now placed in the middle row and then also in the middle column. So now let's see if we can also move it around. So therefore, let's change here the cursor coordinates. So we're going to say here game.cursor row should, for example, equal to 0. And then game.cursor column should also be equal to 0. And now if I run it like this, then the cursor is here depicted in this first cell. And then, for example, if I increase the column by 1, then the cursor moves to the right. And if I increase the row by 1, then the cursor here moves down. So as you can see, our code is working. So now one last thing that I want to do is here is to simply add some comments. So therefore I've prepared already these comments here. So for this block of code, I simply want to say that comment here that says determine if the cursor should be rendered. And then the other comment that I want to add is this one here. And I want to put this in front of this if statement here. And this then simply says apply game state specific rendering words. Okay, so those are now all the changes for our way of rendering the cursor. So therefore then we can check off here the next point in our to-do list. Then next we want to implement the cursor movement in the actual game. So therefore then let's go here to game.py, and here let's first import this helpers.py file. So we're going to say import helpers as h. And then again, we're going to first create here an instance of our class. So we're going to say game equals h.minesweeper game. And then here, what I want to do before the game actually starts is I want to show our grid here. So within this init method, I'm going to call this show grid method. Then another thing that I want to print out before the game starts are the actual controls for the game. So in order to do that, I've prepared here this constant. So this is called controls, and it says here controls are WASD to move the cursor and then Q to quit the game. So we're gonna use keyboard input. So then here in our game.py file, let's print out those controls. So we're gonna say print h.controls. And now to create the game loop, what we're gonna do is we're gonna create here a while loop. And then in order to keep the game running, we need to keep track of the current game state. So therefore then here we're going to create another attribute, and we're going to call this self.state, and we're going to set that equal to active. So then here in our game.py file, we can then simply say game.state. If that is equal to active, then the game should be running. And then here the first thing that we want to do in the game is to get the keyboard input from the player. So we're going to say here key equals something. And then here to get the input or the keyboard input from the player, we need a specific library. Namely, we need to import here this MSV CRT library. So then here we can then say MSV CRT. And then here we're going to use this get character function. So with that, then we can get the keyboard input from the player. So then let's first implement here the functionality to quit the game with Q. So therefore then here let's create a comment that says quit game. And then here we're going to say if key is equal to the binary Q, then we simply want to break our while loop. So now let's see if that is working. So therefore let's open here the terminal, and then we're going to run this game.py file. So if I press enter, then the controls are printed, and here our game board. And now if I press any key other than Q, then nothing happens. And if I press Q, then the game stops. So this is working. So now let's implement the functionality for moving the cursor around with WASD. And let's start with moving the cursor up. So we're going to create here a comment that says move cursor up. So here then we're going to say else if key is equal to binary W. Then what we want to do is we want to decrease our cursor row here. So we're going to say game.cursor row minus equal to 1. And then after that, we simply want to show the grid again. So we're going to say game.show grid. So now let's see if that is working. So let's run this file here again. And now if I press W, then you can see that the cursor now here is moving up. So now let's press Q again. So now let's implement the same functionality for moving the cursor left, down, and right. So therefore, let's just copy here this block of code. And then we're going to say move cursor left. And we're going to do that with A. And then we simply want to decrease the cursor column by 1. Then next, we're going to say, or we want to move the cursor down, and we're going to do that with S. And in this case, then we want to increase our row. And then lastly, to move the cursor right, what we're going to say is here the comment says then right. And then here we're going to use D. And then here we're going to use increase the cursor column by 1. So now let's see if that is working. So let's run, open the terminal again and then run this file. So now if I press W, the cursor moves up. If I press S, then the cursor moves down. If I press A, then it moves left. And if I press D, then it moves right again. So this is working. However, I would like to make here a change. Namely, instead of always printing here a new grid, what I want to do is I want to simply overprint the previous grid. So therefore then, what we need to do is here to go to our show grid method. And then here we're going to create a new parameter. So we're going to call this overprint. The default value for that is going to be false. And then here within the function, we're going to say if overprint. Then what we want to do is we want to move the cursor a certain number of lines up. So in order to do that, I've prepared here a helper function. So let's paste this here at the end of the file. So this is called move cursor up, and the parameter here is n lines. And here I'm simply making use of this NC escape code, where I then put in here the number of lines. And then here I set the end parameter equal to an empty string, because by default this is a new line character. However, with this print statement here, I want to stay on the same line. So now we can use this move cursor up function in our show grid function. So therefore then we first have to specify how many lines we want to move up. So therefore let's create here a variable called n lines. And now let's think about how many lines we need to move up. Namely, if you look at the grid, then obviously we need to move the number of rows up. So then here we can simply say n rows. And then, however, we need to add 2 more lines to this. And that's because of this here upper border and of this, because of this lower border. So let's then add also here a comment. So let's say then simply upper, lower border. And then we can call our move cursor up function and then put in our n lines. So now then here in our game.py file, we obviously then have to set the overprint parameter equal to true. And now let's see if that is working. So let's open the terminal again, run this file. And now if I press W, the cursor moves up. And as you can see, we don't print new grids. However, we always overprinting the current grid. So our code is working. So therefore, let's here quit the game and then close the terminal. And then we can go back here to our nodesmd file and then check off here the next to do in our list. Then the next to do is to ensure that the cursor can't go out of bounds. And to demonstrate what I mean by that, let's open here the terminal, and then I'm going to run this game.py file again. And then here, let me move to the top row. And now if I press W again, then the cursor, so to say, here moves out of bounds. And then if I move, for example, to the right by pressing D twice, and then moving down by pressing S, then you can see that the cursor now is here in this position. So this is now what we want to take care of. So to make sure that this doesn't happen. So therefore then we go here to game.py, and then let's start here with the case where we move the cursor up. So what we're going to do is here, we're going to say that game.cursor row should be equal to the returning value of this built-in max function. So now I'm just going to write out the code and then explain after it what's going on. So here I'm going to first specify a 0, and then here I'm going to say game.cursor row -1. So now to show what's happening here, let me open again the terminal and then run this file again. And then here, let me go here to the top bottom left corner. So now in this case, game.cursor row is currently 8. So then if I then press W, what we're going to calculate is 8 minus 1. So this is going to be 7. And then this function here is going to return the maximum value of 0 or 7. So this is going to be then 7. So then cursor row is going to be 7. So therefore then the cursor here is moving up. And then this repeats if I go here up. And then, however, in this position, game.cursor row is currently 0. So therefore then we calculate 0 minus 1. So the result of that is going to be minus 1. And then this max function is going to return the maximum value of 0 or minus 1. So this is then going to be 0. So therefore then game.cursor row is not going to change. And therefore then we don't go out of bounds. So for example, if I now press W, then you can see that here nothing happens. So this is how we can take care of this problem. So now let's do the same thing here when we move the cursor to the left. And here you can basically just copy this code and then paste it. And then here, instead of using cursor row, we're going to use the cursor column. And then here for the case where we move the cursor down, what we're going to do is basically the opposite. So instead of using here the max function, we're going to use the min function. Then here, instead of specifying the minimum value for the cursor row, we're going to specify the maximum value for the cursor row. And it's going to be here n rows. So we're going to say h dot n rows. And then here we have to subtract a 1 because in Python we have a 0-based index. So the maximum value for the game cursor row is not going to be 9, but it's going to be 8. And then after that, we're going to say game dot cursor row and then plus 1. And then here we can simply copy this again. And then here for the case where we move the cursor to the right, you can just paste this. And then here we're going to use n columns. And here we're going to use cursor column. So now let's see if that is working. So therefore let's open your terminal again and then run this file. So now if I press the W key, you can see that we don't go out of bounds on the top. If I go to the right, then you can see that we don't go out of bounds on the right. If I go down, we also don't go out of bounds here at the bottom. And now finally, if I go to left, we also don't go out of bounds here on this left side. So our code is working, and therefore then we can check off here the next point in our to-do list. And then the last to do in this section here is to hide the terminal cursor. So to demonstrate what I mean by that, let me open again here the terminal. And then I'm going to run game.py again. And then sometimes what happens is that when we move our cursor around here in the game, then sometimes it can happen that this terminal cursor here starts to glitch. So let's see if that's the case. And there you've just seen how the cursor glitched. So that's what I want to take care of now. And therefore we're going to make use of some ANSI escape codes. So let me just copy those and then paste them here into helpers.py. So we have these two escape codes. So the first one here is for hiding the cursor and the second one is for showing the cursor again. So then what I want to do is here within init, before we start the game, I want to hide the cursor. So here I'm simply going to say print hide cursor, and then I'm going to set this end parameter equal to an empty string, because by default it's a new line character. However, I don't want to move to the next line with this print statement. So this is where we hide the cursor, and then within game.py we're going to show then the cursor again here. So at the end of this file, after this while loop, we're going to say print h.show cursor, and then we're also going to set the end parameter equal to an empty string. So now let's see if that is working. Therefore, let's open the terminal again and then run this file again. And then here, as you can see, when I move the cursor around, the terminal cursor is hidden. And then if I quit the game, then you can see that the terminal cursor now is shown again. So our code is working. However, I want to make two small adjustments. And the first one is the following. So if I run this file again, then as you can see, before I make my first move, this terminal cursor here is actually still shown and not hidden. And then only after I make my first move, then it gets hidden. So that's the first thing that I want to take care of. And that is easy to do. Namely, therefore, we just have to set here the flush parameter in this print statement equal to true. So now if I run the file again, then you can see that the terminal cursor is immediately hidden, even I haven't made a move yet. Okay, so this is working. So that's the first thing that I want to adjust. And then the second thing is that here in game.py, this print statement where we show the cursor again is after this while loop here. So if there happens to be an error in this while loop, then we won't reach this print statement, and then the cursor in the terminal will still be hidden. So for example, let's make here an error within this block where we check, or where we make the cursor move up. So here, let's simply say 5 divided by 0. And then let's run this file again. And now if I press W, then you can see we get this 0 division error. And then you can also see that here the cursor is actually still hidden in our terminal. So to get rid of that, or to take care of that, what we're going to do is we're going to put this while loop here into a try block. So here we're going to say try. And then here at the end, we're going to say finally. And here we're going to put in this print statement. So then what's happening is that even if there's an error here in this while block, we're still going to execute here this print statement where we then show the cursor again. So let's see if that's the case. So open the terminal again and then run here this file. And now if I press W, we again get a 0 division error. However, now the cursor is again shown. So this is then working. So therefore then let's here delete this line again. And now before we check off here the last point in our to-do list, I want to add 2 more comments. So the first one is going to be this one here for this print statement where we show the cursor. So this simply says ensure that the cursor is shown again, even if there's an error in the try block. And then the second comment that I want to add is here after this print statement where we hide the cursor. And here I'm simply going to say hide cursor for cleaner game aesthetics. Okay, so this is now our code. So let's go back here to notes.md. And then here we can check off this last point in our to-do list. And therefore then we have checked off all the points in this section, which is about the cursor movement. So then in the upcoming video, we're going to start working on the section which is about revealing cells. So thanks for watching, and hopefully I will see you in the next video.